Hi, my name is Brianna Poon, and this is my lab report for Lab 1 in Physics 2212. So the purpose of this lab is to prepare two charged pieces of tape and observe their interactions and also create computational models to approximate the amount of excess charge on one piece of tape. And then some fundamental principles I use here are Newton's second law, force equals mass times acceleration, where the gravitational acceleration near Earth is 9.81 meters per second. And then I also use Coulomb's law, which is force is equal to k q1 q2 over r squared, where k is equal to Coulomb's constant and q1 and q2 correspond to the two charges. And I also use the electric field of a point charge where E is equal to kq over r squared, where again k is Coulomb's constant, and then use this to relate back to force through this formula down here, which says that force is equal to charge times electric field. So the procedure of this experiment was to prepare two pieces of charged tape and observe their interactions by floating one piece on top of the other and measuring the distance between them. And then I use a computational model to estimate the amount of excess charge on one piece of tape. So the assumptions in place here are that both tapes act like point charges from the center of the tape, and they both have the same amount of charge, and there's negligible air resistance. So here's a model of what my experiment looked like. And so the initial conditions are that the tape length was 0.168 meters, tape mass was 0.000168 kilograms, and the distance I measured between the two tapes is 0.026 meters. And in this scenario, the system is tape B, and the surroundings is everything else, including tape A. So here's my model for the point charge model. So up top, I have my constants, and then with this model, I'm assuming that the net force is 0 since the electric force and the gravitational force will cancel out. So what I did is first calculate the gravitational force and then use that magnitude to calculate the electric force. And then I was also able to determine the charge of the tape using that information, as well as the number of deficient atoms and the ratio between atoms and electrons. And so by testing like the relationship between the charged tape and different kinds of charged objects, I determined that the tape is positively charged. So there are deficient electrons in the tape. And using this model, I was able to determine that the magnitude of both the gravitational and electric forces is 1.64 e to the negative third. The charge on the tape is 1.1 e to the negative eighth. The number of deficient electrons on the positively charged tape is 6.95 e to the 10th. And there's also one electron for every 4.6 e to the 6th atoms. Okay, so here's my computational model for the line charge. So this was created to make my calculations a little bit more accurate. So it kind of uses the same concepts as the point charge model, but distributes the charge of the tape along a line instead of just a point, so that it's a little bit more accurate. And so I have my constants and then the E field calculation, and then as well as the iteration between each individual point in the line charge model to calculate the electric field for each point. And then this was just to model the different vectors and arrows on this model here. So each of the green vectors represents the individual electric force vectors that the bottom tape exerts on the top tape. And then the white arrow is the net electric force, and the yellow arrow is gravitational force. And as you can see, they directly oppose each other, but the magnitude of the electric force is a little bit smaller than my gravitational force, which indicates that there may have been some sources of error. So some errors that I may have encountered are inaccuracy in measuring the length of the tape and the mass of the tape, as well as the distance between the two tapes, and encountering some loss of charge through mishandling the tapes. So if electrons were positive and protons were negative, the observations in the experiment would remain the same since opposite charges will still repel each other. However, the tape would instead be negatively charged and have excess electrons, meaning that the electric tape would point inwards instead of outwards. And the estimated charges from the point charge and line charge models are different because the point charge model is an oversimplification of real life electric field interactions, and the line model accounts for a more even distribution of charge across the whole object, meaning that it results in a more accurate model, and therefore the charge from the line model is likely to be closer in value to the real value. So that's the end of my report, and thanks for listening.